Welcome to another unit in this Excel course. This time I'm going to talk about how we can use Excel to calculate Spearmans Rank correlation coefficient. Here I have a data set of exam results, exam marks, and while some might argue that they can be interpreted, especially if I don't have any failing grades, as metric data, some others might argue that they are only ordinal in nature. So assuming at this point they are ordinal data, we can use Spearmans Rank correlation. Well, we could even if they were metric, but here we could still apply Spearman. However, the problem is, if I try to do this, there is nothing like Spearman here in Excel. So I have to do this more or less myself. And luckily, it's not this hard, because what Spearman actually does is just rank the two data sets, the two variables, and then apply Pearson's correlation coefficient to the ranked variables. So I can use the ranking function, here the rank average or equal. Average is just if I have more results that have actually the same value, as here Hans and Irina with a 2. They would not only get the same value, but if they, for example, would cover the ranks 5 and 6, both of them would be assigned 5.5. If I use the equal, they would both be assigned 5, so the smaller of the two ranks. Well, basically I could use both. In my experience, average makes a bit more sense. So we go with average. I select the corresponding number and the frame of reference. That's the whole variable. I close this and see this is at rank 16. Well, how do I get this? Well, here the highest number is rank 1. I could change this in the order, but in the end it doesn't matter, because as long as I use the same order for both rankings, I will get the same result for Spearman. So whether I use an ascending or descending order doesn't matter. If I use an ascending one here, I only have to use an ascending one here as well, and vice versa. So I keep it as is. To make my life a bit easier, I'm just going to fix here the rows, so that I only take here those 23 observations. Then I can simply use the autofill function, pull this down, and the autofill function to pull this to the right. So I get this for everything in column B, and then I get the same stuff for everything in column C. So those are my two ranked data sets. And Spearman, as I said, does nothing else than just apply Pearson's correlation coefficient on those two ranked data sets, two ranked variables. So I use here Correl for Pearson's correlation coefficient on the first and on the second, giving me as a result Spearman correlation coefficient of minus 0.16112. If, for comparison's sake, I calculate Pearson's correlation coefficient of this data, so of the original data, I get a value of minus 0.14 something. So they're pretty close. So I can assume that the data is more or less linear in its relation. So linear relation between the results from exam 1 and exam 2. However, as both are pretty small, I know it's not this strong, not this clear of a relation that exists there. There are quite some where the relation is not as pronounced as it's supposed to be here. Also, I see both are negative, so a positive result in the first one usually goes hand in hand with a worse one or bad one in the other one, and vice versa. So there's usually not people who have very good results in both of them or very bad results in both of them. Again, that's on average. So yeah, there are some exceptions, but not all of them. And that's all I could tell you on how to work with Spearman's correlation coefficient in the context of Excel. So this then already concludes this small session. And if you want to see more, feel free to visit the rest of the Excel course or have a look at the corresponding playlist. I say goodbye and see you next time.